Hi everyone. So the goal of this video is to understand renewable energy. There's many reasons why I want you to know this. One, it's on the current unit of energy. Two, it's very relevant for your project that we're working on in class right now about building a net zero school. And then three, there's a lot of real world implications. We, and especially you, because you're younger, have to think about how are we going to get energy in our world. We can't rely on fossil fuels forever, so we have to start thinking about renewable energy sources and what can we do and what are the technologies that are really going to change our society. So I think this could be really a really good lesson, not just for physics but for life. All right, so what I want you to know is to be able to explain the benefits of renewable energy, give the pros and cons of different renewable sources, and argue with evidence to explain which renewable resource are best for like a certain situation. So you need to be able to like list the renewable energy sources, give at least one pro and one con, and then write a few sentences to explain what renewable resource you would use for a certain situation, considering cost, space, environmental impact, things like that. All right, so renewable versus non-renewables. Renewable just means like, well, let me just read this definition here. Energy resources are considered non-renewable if they cannot be replenished, like made again, in a short period of time. On the other hand, renewable energy sources are replenished naturally, such as solar and wind. So non-renewables, and actually, let me just show you this next picture here. So here are some common examples of renewables and non-renewables. So renewables are like wind or hydropower or solar or geothermal or biomass. These are all things that we don't have to do anything to make it happen, and they will always happen. There'll always be wind, there'll always be water, there'll always be the sun. On the other hand, oil, coal, nuclear, natural gas, like these three especially, we have to get out of the ground, and there's only so much underground that we can extract. And then nuclear, it's not necessarily renewable. There are only so much nuclear, elements that are reactive that we could actually extract energy from. It also, there's one problem for all these is the waste that they make. They can really be disruptive to our environment and our air. You hear climate change, global warming, whatever you want to call it. Those are major impacts that happen from non-renewable energy sources. All right, so there's so many benefits to renewable energy sources. One is it can reduce carbon emissions and reduce air pollution. That means that we'll have less global warming or less climate change. We'll have improved public health because we'll have better air. We can have more jobs, jobs created through these renewable energy industries, companies that are making solar panels, companies that are making wind turbines, things like that. And that means increased US energy independence. If you're aware of some of the issues going on in our world right now, some of it has to do with land and oil, some of the conflicts historically that have happened in the Middle East, even the war with Russia and Ukraine. Gas prices really kind of went crazy when that war first started. And that was because we are dependent on a lot of these oil-rich countries. And that might mean that we have stable energy prices if we start using renewable energy sources. They're reliable, they can be resistant to any changes in the world, and they are becoming more affordable. They are still expensive, but they're not as expensive as they were in the past. All right, so let's dive into some examples. And I'm sorry if this video is long, but there's a lot of examples I need to cover. I'll try to be as short as I can. So solar, you might be familiar with solar. Solar energy hits a solar panel. Without going into too much details, the solar panels are made out of special materials that basically have like electrons that kind of get excited. And that's really what an electric current is. Electric current is like excited electrons that you have like an electric charge moving down a wire. So that energy is exactly directly connected to some kind of wire and you get electricity. And that can be used to light bulbs or whatever electrical things you have in your classroom or your school or wherever. Pros and cons, it's renewable, reduces electricity bills and long-term savings. You'll find that a lot of our renewable energy sources are going to have these pros, all right? Some cons, and solar panels are actually pretty good. You need some space, like a roof or maybe an open field. It only works with good sunlight, so it really is only working a few hours every day, and it can be pretty expensive, $20,000 for an average house installation. That would be even more for a big school. But like I said, in the long run, it would be a good investment because you'll save more money from electricity than you would from this upfront cost. So yeah, you pay upfront a lot, but then you save money for a really long time. And at the end, you end up saving money. All right, wind energy. So the kinetic energy of the wind causes the blades of the fan to spin. So these blades are going to spin, and there's some gears back here, and it's connected to an electric generator. And the electric generator makes electricity. Electric generator generates electricity. Okay. Um, Without going into too much details, that electricity can be sent down the tower through some wires and then put onto our electrical grid or used however we want. So again, same pros as before. Renewable, it's great. Some cons, you need a lot of space. They can be very tall. I mean, the ones that we might be using for a school might be down on this range, but some that you might see like out in the middle of nowhere where those big wind farms are, they're huge. I mean, 100 meters tall. That's longer than a football field. That's crazy. Um, they can be very expensive. I mean, a small one costs a lot of money. There are some environmental effects. They do kill some birds, and there are some community effects because they aren't so pretty to look at, and some people might not want them as part of their, their skyline when they look at their town. Hydroelectric. So hydroelectric means that you take some water and you take the movement of the water, like at a dam, and that water can actually make electricity. Just real quick, if there's water here, the water kind of comes in through this little tube. It makes a turbine spin, and then that spinning can make electricity. So again, the kinetic energy of the water causes this turbine to spin. The generator spins, and the generator generates electricity. And that electricity can be sent to power lines to power a town. So again, same pros as usual for renewable energy sources. You usually need a big river to make this work. The river needs water, obviously, but I say that because water levels can fluctuate by season. Some of these dams that are especially built on the west coast, sometimes the rivers kind of dry up and there isn't a lot of water flow and you don't get as much energy because of that. Dams are very expensive to build, and you would really have to get maybe lots of cities or a whole state to decide to build a dam. And there are some environmental effects. They can affect the river ecosystems. For example, like if fish were trying to swim upstream or downstream, they would no longer be able to do that because this dam is kind of preventing their normal life. Just to kind of take a little tangent for a second, what we've been talking about with turbines and generators isn't much different from how we usually get electricity. So when we burn coal or natural gas to get electricity, basically what's happening is we have a turbine spinning. That turbine makes a generator spin, and that generator is making electric energy. That electricity can be sent to our homes and towns and wherever. The way coal and natural gas are used is you have some kind of coal, it gets burned, and it heats up some water. It turns it into steam. And so, if you ever heard of steam engines, if you've been looking at the Industrial Revolution in any of your history classes, this was a huge breakthrough, creating steam engines. And so, the steam makes something spin, and you can use that spinning to make it into electricity. You can use that spinning to make a vehicle move. The steam is pushing this turbine to spin, and it's making this generator spin in this case to make electricity. Okay, that's a very short version of how these turbines and generators work in our usual lives when we use non-renewable energy sources. We're basically using that same technology for water and for wind energies now. All right, geothermal. So geothermal basically means that you're going to get the heat out of the ground and use that heat to heat up your building. You can have pipes that go horizontally and kind of zigzag through underground, or you could have them zigzag vertically and go way down underground. Okay, and then they're connected to some heat pump that can pump that heated water through your house. All right, so geo means earth, thermal means heat, so we get heat from the earth. Tubes that are hundreds of feet long zigzag underground. There's actually a special liquid. It's not always water. It's actually usually like a special like coolant that has some special properties of like really low boiling points. Anyways, the idea is like we can get heat to heat up that liquid in the tube. All right, so the heated liquid can be pumped through a home to heat the home. There are some really good pros to this one. It's, as usual, the usual pros of any renewable source, but it's also very efficient. So if you've done lesson 4 and you've looked at efficiency, this percentage might make sense. It's actually a really high percentage. It's kind of crazy how efficient they are. And it's almost mind-blowing that you can get over 100%. But basically, you take a little bit of power, the power to like pump this liquid through a heat pump, but then you're also kind of getting a lot of energy from the earth. So overall, it's really efficient. You're getting a lot of thermal energy delivered to your home that's kind of free. It's just sitting there underground and you're just extracting it. It is very expensive. I mean, for a house, it's very expensive. For our school, it would even be more expensive. But again, it could be worth it in the long run for how much money you save. Um, Instead of paying for oil or instead of paying for gas, you just have this system and it kind of pays for itself. All right, that was a quick rundown of all of the renewable energy sources that I want you to be aware of. There are some other ones out there, but I think those are your major ones that you can start thinking about, how is this important for our future, like our real future in society, but also how's it related to your project if you're trying to build like a net zero school, how can you use maybe some of these? And, if you're given a situation, can you tell me would it make sense for you to have one of these renewable energy sources wherever you are, whatever you're building, a house, a building, a school, whatever. All right, I know that video was a little bit longer, but I think that's all you really need to know. There might be a few questions for practice, and then that's it.